In this video, we're going to take a look at the topic of linear modeling. In general, modeling is when we take a real-world situation and create an equation to model that situation. This equation that acts as our model allows us to answer questions and solve problems about that situation. Let's take a look at one. Renting a truck for one day costs $20 plus 15 cents per mile. Create a model for this situation. So if we wanted to come up with a model for this situation, we're trying to determine the overall cost, which we could call C. And then as we look at the way that this model is going to be created, we're going to pay 15 cents per mile, and we don't know how many miles we're going to drive. So let's assign a variable to that and call it X. And it's going to be 15 cents for every mile plus $20 on top of that. So if we look at the equation we're going to set up, we want to make sure to use a decimal to represent 15 cents. And it's going to be 15 cents per mile. So we want to multiply 15 cents multiplied by the number of miles we're going to drive, which we called it X. So we're going to add the $20 charge on top of that. And now we've created our linear model. The cost in this situation is our dependent variable. And that's because the cost depends on how many miles you drive. The miles, then, what we have labeled as X, is our independent variable. And so here we've created a model with an independent variable and a dependent variable for this situation where you pay $20 to rent the truck plus an additional 15 cents for every mile that you drive. Now let's put that to use. Same situation, renting a truck for one day costs $20 plus 15 cents per mile. Find the cost of renting this truck and driving 25 miles. So we're going to start out by just restating our model. That was 15 cents for every mile plus $20. What we need to do is find the cost if instead of using X for the variable, we know we're going to drive 25 miles, so we can put 25 in where the X is. And when that happens, our cost is going to be 15 cents per mile times those 25 miles plus $20. So we'll multiply 0.15 times 25 and get $3.75 to add to that $20 cost. And so the total cost of renting the truck and driving 25 miles is going to be $23.75. We can also solve a slightly different type of question. Same situation, renting a truck for one day costs $20 plus 15 cents per mile. If a person has $30 to spend, how many miles can they drive? So this question is a little bit different than the last one. We're still dealing with the same situation, so we're still going to use the same model. 15 cents times the number of miles plus $20 is the total cost of the truck. But this time, what's a little different here is instead of knowing how many miles they're going to drive, that's what we have to find out. What we do know here is what the total cost is going to be. So in this case, we know the total cost is going to be $30. It's 15 cents for every mile plus $20. And I've created an equation that I can solve. Now I have to solve for X to find out how many miles the person would be able to drive. So the first thing we'll do here in order to start working toward getting the variable by itself is to subtract 20 from both sides. On the right-hand side of my equation, those 20s cancel, and that leaves me with 10 equals 0.15 times X. And since I'm running out of space, we'll move that over here. I have 10 equals 0.15 times X. One more step to get X by itself. I need to divide both sides by 0.15. On the right-hand side, those cancel, leaving me just the X. And on the left-hand side, I've got 10 divided by 0.15, which gives me 66.666 repeating. Question here told me to round to the nearest hundredth, so that's what I'll do. I'll find my hundredths place and I'll look one space to the right. Since that number is 5 or bigger, we are going to round up, and the number of miles that this person could drive is 66.67 miles. Here we've created a linear model. We've used it to find out what the cost would be if I knew the number of miles they would drive. And I've also found out the number of miles they could drive if I knew what I wanted the total cost to be. So pretty flexible, pretty useful linear model. I've been talking about a linear model this whole time without really describing what that is, so we'd better do that too. A linear model has a consistent rate of change. This is something that you may be familiar with from algebra. It was called the slope. And when we have a consistent rate of change and no variable in the exponent, you'll notice here the variable in this, our independent variable x, is not in the exponent. There's no exponent at all. And that's an indication that we have a linear model. The general form of our linear model is the equation of a line, y equals mx plus b, where m is our consistent rate of change, and b is a constant, a number that doesn't change. In the linear model that we set up earlier, that was the $20 fixed cost that was associated with renting the truck. A couple of quick things about linear models is they can represent growth, and that happens when m is a positive number. When our consistent rate of change is a positive number, we see an increase. That's what we saw in renting the truck. As the number of miles driven went up, the total cost of renting the truck also went up. And you can also see decay, and you'll see that when m is negative. An example of this might be you have a bank account set up to pay your electric bill every month, and you're on an equal billing plan. So every month, your electric bill is exactly the same, and you have this one account that pays it. There's going to be a consistent rate of change, and the amount of money in that bank account is going to consistently be going down. And that's an example of a negative rate of change, and that's an example of linear decay. And that's how we'll use models to solve problems and answer questions.